So hi friends, today we are going to see about the topic AVL tree and how the insertion will be made in AVL tree. So AVL tree is nothing but it was introduced by Adelson, Welsky and Landis. So it is called as AVL tree and it is a balanced binary search tree. So in the sense balanced binary search tree, it should satisfy the balance factors. So balance factors are nothing but it is a values where -1, 0 and +1. So the AVL tree should satisfy these values, it's -1, 0, +1 to make it as a perfect AVL. So if the values are greater than these, -1, 0 and +1, and if it is 2 or -2, we should balance the tree to make to come to these values -1, 0 and +1. We have to balance these values to come to these -1, 0 and +1. Okay, let us see with an example. So how these balance factor for an AVL tree is calculated. So let us see with an example. Let us consider a tree where the node are A, B, C, D and E. So these are the nodes and how the balance factors are calculated. Here the balance factor of D is 0 and E is 0 and C is 0 and B is 0 and A is -1. So how these values are calculated? So it is nothing but the height of left subtree minus right subtree, or else right subtree minus left subtree. So we can use either one of these formulas to calculate the balance factors. So here the node D has no left and right, so it is 0, and if it is E, there is no left and right, so the balance factor will be 0. For C, the left side height of left subtree is 1 and height of right subtree is also 1, so 1 minus 1 it's obviously 0. And for node B, there is no left and right, so it is 0. And for A, left side is 1 and right side is 1 and 2, so 1 minus 2 it is -1, so the balance factor will be -1. So here there is no imbalance in the AVL tree, so it is a perfect AVL tree because it just satisfies these values -1, 0 and -1, 0 and +1. So there is no imbalance occurs, so it is a perfect AVL tree. So let us consider another example where the imbalance occurs. Consider another example where A, B, C, D and E. Let's consider this example. The balance factor for E will be 0 because there is no left and right, so it is 0. And for D, it is left subtree minus right subtree, it is 1. And for B, it is left side is 0 and right side is 2, so 0 minus 2 minus 2. And for C, it is 0. And for A, 1 minus 3, it is -2. So here the imbalance occurs because here comes -2 and the balance factor of A is also -2. So there is an imbalance occurs in this tree. So it should get balanced. So how the tree will get balanced? By using a concept called rotations. So here come the concept of rotations to make the imbalanced tree as a balanced tree, because AVL tree is a balanced binary search tree, so it should get balanced by using a concept called rotations. So rotations there are two types of rotations. One is single rotation and another one is double rotation. In single rotation we just called as left rotation and right rotation, and double rotation it is called as left right rotation or else right left rotation. So we just, these are the two types of rotation we just apply in the AVL tree to make it as a balanced tree. So the single rotation is simple method, but in double rotation just somewhat complex. So we just clear with the help of a trick which I will be saying in the next video. So in this video we will be seeing about the tree by applying it to make a perfect balanced tree by using a single rotation. So you will be seeing the double rotation in the next upcoming video. So let's consider an example. So for example, we need to insert the values 20, 30, 40 and 10. So 20 will be the root node and 30. So it is, so will be considered the binary search tree. So the values which are coming in the left side must be less than the node, and the values which will be coming in the right side will be greater than the root node. So this is called as a binary search tree. That is, left side values will be less than the root node and right side values will be greater than the root node. So 30. So 30 is greater than 20, which will be coming in the right side, and 40. 40 which is greater than 20 and 40 is greater than 30, which will be coming in the right side. So we need to calculate the balance factor. For 40 it is 0, and for 30 it is left subtree minus right subtree, which is minus 1, and for 20 it is left side is 0 and for right side is minus 2. So we need to consider 2 points when the imbalance occurs. So here comes the imbalance because it comes minus 2, so there is an imbalance in this tree. So we should balance this tree. So we need to note 2 points where the imbalance occurs and after inserting which node the imbalance occurs. So after inserting 40, the imbalance occurs at root node 20. So the node is inserted as right of right subtree. So the 40 is inserted as right of right subtree. So the imbalanced node must be rotated to the left. You need to consider this point because it is an important point, because so the node 40 is inserted as right of right subtree. So the imbalanced node must be rotated to the left in opposite direction. If it is inserted as right of right subtree, it should get rotated to the left. So this is the imbalanced node and other nodes will come as it is. 30, 40 and 20 will come to the left. So you can check now. It is 0, here comes 0, here also 0, because left side minus right side, left subtree minus right subtree, it comes 0. And you can also check the 20 is less than 30 and 40 is greater than 30. So we just balance this tree. So another value will be 10. 10 will come to, so 10 is lesser than 30, so it comes to left side, and 10 is lesser than 20, it comes to left side. So here comes the balance factor is 0, here comes 1, and here comes 2 minus 1, here comes 1, and here it is 0. So it is already balanced. So it just satisfies these balance factors minus 1, 0 and plus 1. So it just balanced. So this is the final tree for this question. So if it is the node is inserted as, that is after inserting which node the balance, we need to consider the point after inserting which node the imbalance occurs at which node. So the node is inserted as right of right subtree, so the imbalance node must be rotated to the left. This is the first method for single rotation. So if it is node is inserted as right subtree, so rotation must be left. If it is the node is inserted as right subtree, the rotation must be left. So let us consider another example where the right rotation applies. Let's consider another example. 20, 10, 5, 30. So 20, 10, 5 and 30. So 20 will obviously the root node, and 10 is lesser than 20, so it comes to left side, and 5 is lesser than 20 and 5 is lesser than 10, so it comes to left side. So we need to check the balance factor. So here comes 0, here it is 1, and here it is left side is 2, so 2 minus, there is no node in the right side, so 2 minus 0, it is obviously 2. So there is an imbalance occurs in this tree, so we should need to apply the rotation. So where the imbalance occurs at 20, after inserting which node? 5. So the 5 is inserted as left of left subtree, so the imbalance node should be rotated to the right. Okay, you need to consider this point. As you consider in the previous example, the node is inserted as node is inserted in the right of right subtree, so we just make the rotation to the left. Here the node is inserted as inserted to the left of left subtree, so the imbalanced node must be rotated to the right. So the final tree will be 10, 5 and 20 will come to left side. So here comes 20. Okay, so the balance factor will be 0, here comes 0, here comes 0. So there is no imbalance occurs. Let us proceed with the insertion. So next node is 30. 30 is greater than 10 and 30 is greater than 20. It's 30, so we can check the balance factor. Here it is 0, there is no node left and right, so it is 0. Here 0 minus, the balance factor will be minus 1. Here comes 0, here 1 minus 2, here comes minus 1. So it just satisfy these balance factor, minus 1, 0, 1, plus 1. So there is no imbalance in this tree. So this is the final tree for this question. So these are the simple examples where the left rotation and right rotation applies. So in this example it just applies if the node is inserted in the left subtree, the rotation will be right. So the node is inserted as left of left subtree, so the node will be rotated to the right. So in these two examples you need to consider if the node is inserted to the left of left subtree, the rotation must be right, and if the node is inserted to the right of right subtree, the rotation must be left, that is in opposite direction. So in which direction the node inserted, in the opposite direction you should make the rotation. This is the important point you need to consider in the single rotation. So you can just refer more complex examples by applying this single rotation, and it is one of the easiest method where you can apply to a tree to make it as balanced. So thank you guys. You just see about a single rotation. You will be seeing the trick to solve the double rotation in the upcoming video. So thank you for watching this video. Please subscribe to my channel. Bye.